switch statements now. As we saw in the last example with the if, else if, and else if, adding too many else if conditions make the code little difficult to read. So there is a better way of handling such situations in Swift, and that's a switch statement. As you can see in this example, very similar to the example which we saw before with if-else conditions, we're doing more or less the same thing. We're trying to see which language we are learning, and but here in the switch case statements, instead of us having a huge if-else conditions, we basically switch against the value of the variable, which is Swift in this case, and definitely this could have been let, right? I'm not really changing the value here, so it could have been let. But I am going forward and checking to see whether this matches a given set of choices. And those choices are listed as cases in the switch statement. The way the switch statement works is that it is a switch statement followed by the variable against which we want to apply the switch and lists down the possible cases. Now, a few important things to note about this switch statement is that number one, the cases have to be of the same data type as the variable. So here's the variable was of type string using type inference. I really can't introduce a case statement here, which is an integer data type, and say that, okay, I am an integer. Now, this is not allowed in Swift. As you will see, this will result in an error, a compilation error saying that, well, the expression pattern of type int cannot match the value of type string. So they have to be the same data type. It can be conditional, which is true, which we'll come to in a few minutes. The other piece is that the cases must be exhaustive. And what I mean is that with string, what are the possible exhaustive cases? It could see I'm listing on C++, Java, Python, Kotlin, Swift, and does it mean I'm not listing down .NET now? No, Swift has no possible ways of figuring out that your variable actually meant computer languages and not English languages like French, German, and others. Plus, even if Swift was able to understand that the variable actually intended for languages of some sort, it doesn't know the list of the possible languages which are out there. What it means is that for Swift, it's a string. A string can have any possible combination of characters standing together. And C++, Java, Python, Kotlin are just some combinations of the character, and there can be n number of possibilities which are out there. So here Switch is saying that you must be exhaustive. And for being exhaustive here, what it means is you must have a default statement at the end, which is if you are not able to match any of these statements, then what to do with the possibility. And that's handled by the default. Or if everything else fails, what else I am doing. And if you go back to the if else if condition, we were actually handling this with the else block, because if all these condition checks failed, we were having a default condition to actually handle the remaining case, which is falling up in default here. Now for strings, you will always need to have a default because any number of combinations are possible. Same thing with integers. Integers can have any value starting from zero. It can keep going to thousands. So you really don't know what value is going to be possible for integer. Where you can actually drop the switch statement, the default statement is enumerations. Enumerations have a finite set of values, and if you pass an enumeration in the switch statement, then switch will know the possible list of the cases. And if you listed all the cases, it will let you drop the default. And we will get to it once we're talking about enumerations. Next item here, again, if you're coming from different programming background, is that you don't see any break statement. In most programming statements, you will have something like a break lying around here. And you can put that in Swift as I put in here, but that's not required. In Swift, there is not no fall through. Like in other programming languages, what is going to happen is that if you don't have the break statement, and C++ was actually entered as a language of choice, then you will see something like you are learning C++. Then you will see you're learning Java, Python, Kotlin, Switch because they were falling through. Once you hit a match, everything else is going to fall through. Now, if the first language is Python, Java, then you will not see the C++, but you will see you are learning Java, then you're going to see you are learning Python, then you're learning Kotlin. because in those languages, the rest of the cases after the first match just fall through. Not in Swift. Swift, each case is independent. So if you match a case, you're just going to execute the lines, and they can be multiple lines here. And I can say the second line is I am happy. And that's good. It's going to execute the two lines. It's going to execute n number of lines, but it will execute only the lines which are present in the case statement, which is good. You don't need to have those redundant breaks. What it also means is that you now do not have a capability in like or some previous programming languages, which could do something like case Swift, and they will have another case statement here saying Objective C. And then you are learning iOS programming languages. Both can be used for coding on iOS. And that is not allowed because the reason why those previous programming languages used to have a fall through was that so that you can use the cases to club together multiple conditions. You can say that, okay, now if it is your Swift or Objective-C, you're learning iOS programming language, but you can't do that in Swift. And Swift provides much cleaner, much powerful ways of handling multiple conditions in the code. Now let's look at what other options Swift provides. Like I said, okay, we can't follow through. So what does Swift provides to handle multiple conditions so that I don't have to recopy the executable lines of code inside each case statement. Number one is the range operators. Now we covered the range operators. They start with three dots. So basically they have three dots to indicate a range, and they have a left index and right index. And here in this example, what we're going to do is that we're going to ask the user which week we are in. And based upon the range operators, we're going to tell them whether they are in the first quarter of the year, second quarter of the year, third quarter of the year, or the fourth quarter of the year. In this example, we started with a variable, which is of type integer, and we assigned it a value 12. So and I listed down four cases. And in the four cases I pointed was if I'm in week 1 to 13, each quarter has 13 weeks. So if I'm 1 to 13 exhaustive, then I'm in quarter 1. If I'm 14 to 26, then I'm quarter 2. 27 to 39, quarter 3. 40 to 52, quarter 4. So let's try. If I change this to quarter 3, week 3, then I'm still in quarter 1. Okay, that's good. What if I move to week number 23? Now I'm quarter 2. What if I move to week number 50? Now I'm quarter 4. So these range operators prevent those scenarios like in other programming languages. You might have to write case 1, case 2, case 3, case 4, and then depend upon fall through. You don't need to really do that. You just specify a range operator and you're done. Again, you would have noticed that we had to specify default because integer can have any value. It just will not have 52 from 1 to 52. It can have negative values, it can have positive values. So Swift needs to make sure you are handling all the exhaustive conditions, which is any number which is possible by integer. And that's why I had to add a default condition, even though I may know that this condition will never be executed. Moving on, we talked about range operators, and that was one way of handling certain set of values. The other option is to switch and have conditionals inside the switch statements. And these are conditional statements like if some number is greater than something, then I'm going to do Y. And if some number is less than something, then I'm going to do X. Now, let's look at this statement again. It's a weak number condition. And again, I'm starting with 12. And I have my Q1, Q2, Q3 blocks just as they were before. And before my first condition, I have put another case statement. And here I am defining a new variable and it's a constant. I'm defining let week and saying week number. Okay, so I should have probably corrected that one. It's supposed to be week. It's week. And I'm defining let week be where week is less than 1. So I'm trying to handle a condition where somehow the user entered a 0 or a negative number. So I'm saying if week is less than 1, Then let's do this data binding and bind whatever value is specified in week number to the constant named week. And that constant will now be available in this statement. So yeah, I'm saying the week number cannot be negative, but it could very well have been saying that, okay, week number, and I could have printed what the number was here and said that, okay, week number cannot be negative. So let's try with something um, -3. Let's see what happens. I specify -3 and I'm gonna expand my results pane. So it's week number -3 cannot be negative. So I have a handle to the variable which was being used because it's been data binding to week. I can also introduce a condition here and say the case let week where week is greater than 52. Okay, so if week is greater than, then basically I'm going to say that you need to choose the weeks between 1 to 52. And of course, it's integer, so I have some default condition that needs to be handled. So I put something else has happened here. Now let's try entering a bigger number. I'm trying entering 100 as a number. I'm going to say that you must choose something between 1 to 52. So multiple case statements can have multiple conditional statements, and the appropriate conditional statement will be executed, but it will be executed starting from top down. So this will only be executed if all the above were not true. Now let's look at Swift with multiple choices. And in this example, I'm going to simply state is that if I'm going to take some alphanumeric characters, and if you begin with small or capital A, then you are starting alphabet. But if you are anything else, then I'm going to print whether you're a small case letter or your capital case letter. And I will also have a condition for checking for numeric characters and letting you know if you actually entered something which is not alphanumeric. So I take a character and as the input from the user, I simply have a case statement which is comma delimited this time, as you can see. And of course, you don't need to have just two options. You can have n number of options, comma delimited. I just opted with two. And in other scenarios, I didn't really have to worry too much about comma delimiting all the possible small b's to z, like small b, c, d, e, f. I just use the range operator, and again shows the range operator is powerful, can be used even for characters. I use the same thing for capital B to Z. You use the same thing from 0 to 9, and then went forward and defaulted to the remaining piece so that if there's any default character. And now, important thing to note is that again, characters are Unicode characters, so there are a lot of possibilities out there, and defaulting is covering all those scenarios. One another thing to note is that if I write this case statement like is hello and say print hello, here see what happens. Okay, and it errors out. Okay, and it errors out while all my case statements look like string. Why did it error out? The reasoning is that my character was not really my char variable was not really a string. It was a character, and hello is not a character, it's a string. So that's why, again, going back to it must be the same data types. um, but reverting back, I am able to execute my code, and this is how you specify multiple values in Swift. Quick recap, switches are very powerful in Swift, as you would have seen already by now. You can specify multiple values delimited by commas. You can use range operators. You can use conditional statements and data binding to get access to those variables. But important things still are switch statement must be exhaustive. There is no fall through in the switch statements, and they must be at least one executable line of code in each case statement. You cannot have an empty case statement in Swift. Next, we will move on to loops in Swift.